All right, howdy kiddos. So we have a new concept here. However, it's really building on everything you've learned up to this point. So rather than teach you the concept, which the book does a decent job doing, I'm instead going to show you the reasoning why you need to learn this particular piece and really reveal a pattern, hopefully, that you've seen up to this point. All right, so first let's dive into one of the first quadratics that you were solving. And that is a quadratic that you can solve just by using square roots, right? So here we have a quadratic equation. B is 0. That means the vertex is on the y-axis, which means the axis of symmetry is on the y-axis. And you can tell that then if this is a negative number and our curve curves up, that we're definitely going to have roots, right? So step 1 is to add 128 to both sides. After you do that, divide both sides by 2, get x squared equals 64, square root both sides, and you get a nice easy answer of x equals either positive 8 or negative 8. You can see that in the graph. That's a graph of the function. You can see the y-intercept down there at 128. We're good to go, right? That's easy. You can tell whether it's going to be no solution right away, because if it was a positive function with a positive y-intercept in this form, it would curve up and never hit the axis, and no roots, right? No solution. Easy peasy, no problem. And you notice that you have a lot of problems like that, right? You probably got used to it, got pretty easy to solve. All right, then they changed things up and said, hey, b doesn't always have to be 0. What happens when b is not 0? Notice this is almost the same problem, but now we have a b. So what do? I can't just add 128 to both sides and take the square root of both sides like I did before, or divide by 2, right? And then take the square root. If I added 128 to both sides divided by 2, I would have x squared minus 12x equals 64. I could still take the square root of 64, no problem. But x squared minus 12? I can't take the square root of that. I don't know what that is, right? So we have a problem. All right, so we solve our problem a different way. We say, okay, well, wait a minute. If I could factor this and then make both of those factors equal 0, or either one of those factors equal 0, that's the 0 property, then I would know the x values that would make this quadratic 0. That would be the roots of this quadratic equation. So you factor it, right? So we factor this into 2x squared minus 32 times the quantity x plus 4. Set both of those equal to 0. That's our 0 property, right? And we find out that x can be either negative 4, except we solve for this one, or 16. This equaling 0, add 32 to both sides, divide by 2, we get positive 16, right? And this graph right over here shows us that this is a graph of the function. Shows us that our roots are definitely negative 4 and 16. Okay, so similar to before, we've got a negative x-intercept, right? Negative y-intercept. Therefore, we know that this is also not our vertex, and it curves up. So if we have a negative y-intercept and our function curves up, then the vertex has to be below that y-intercept, right? We can't have a vertex above our y-intercept that curves up. That doesn't make sense, not in the negatives. Therefore, since we have a y-intercept below the x-axis, we're definitely going to have roots, right? So we know we're going to have roots here. We can look at it. We don't know exactly what they are, but we know that we're going to have roots here. It's not going to be no solution. If this was a positive 128, we'd have to do some work, right? That would be a positive y-intercept, and we'd have to figure out where the vertex is, because the vertex at that point could be above the x-axis or below the x-axis, and we don't know, right? So things are getting a little bit more complicated, right, with this extra b value here, and we are introduced to the idea of factoring as a way to fix that. Okay, so again, here we have two rational, in fact they're two integers. We have two integer answers, good to go, looks great, easy to graph, no problem, right? Well, what if it wasn't that easy, right? And you have a couple of these in the work we've done so far, but not a whole lot, right? This is almost the same exact problem, except for instead of 128, it's 100. which means we add 100 to both sides. We then divide both sides by 2. We then have x squared equals the 50. Take the square root of both sides. Square root of x squared is x. Square root of 50 is square root of 50, right? It's not a perfect square like it was last time. So now the best we can do is simplify our radical. If you've been doing the radical unit in Khan Academy, you know how I got this. We can simplify the radical or find the square root of 50, which is approximately, because it's an irrational number, approximately 7.07, and then the decimal continues on forever because it's an irrational number, so we round it to the hundredths place here, and it's approximately plus or minus 7.07. And if we look at our graph, we can see that the roots, the function crosses the x-axis at just a tiny hair past -7 and a tiny hair past +7, right? We lost our perfect, nice little integer roots, but we can still do it, right? We can throw 50, excuse me, into a calculator and take the square root of it. Bam, easy. Now, what happens when we have this? Now we got a problem. Now, if you tried to factor 2x squared minus 24x minus 100, you're not going to find any factors for it, right? If I divide both sides by 2, I get x squared minus 12x minus 50. What two factors of 50 can you use where the difference of those factors would give you 12? There are none. Only factors of 50 are 5 and 10, and 5 and 10, or of course 1 and 50. And the difference of those, we got to find the difference because this is a negative number. The difference of those is never going to give you 12x. Remember, we got 12x because we divided everything by 2. We got 50 because we divided everything by 2. So how are you supposed to solve this? This is its graph. It obviously has a solution, right? This appears to be a little bit bigger than -3. So I bet if you tried -3, it would be really, really close. You know, try maybe -3.2. That'd probably be really close. It works. But how the heck do you solve for it? What do you do? Well, that's what section 5 is about. What do you do when you have a quadratic equation that you can't factor and that you can't use square roots to find the solutions? So now we've identified the problem. Section 5 is the solution. It's not the only solution, as we will come to find out, but it is a solution, and it is called completing the square. So now that you have an understanding of the purpose of what you're learning, I hope that you find it interesting to learn the concept of completing the square. All right, hopefully that helped. You're a little curious to dig in. Go ahead and do the quick checks on your own, and I will put out a quick check video here shortly, and then an exercise video for the exercises that I assign. Don't forget, you have a challenge question in Flipgrid. Look in Google Classroom, try to find it. I only have 4 submissions out of 50 possible students that could have submitted. So throw yours in the mix and let's see what you can do. All right, have a good night, and hopefully you're doing well.